This is the full moon above Trinity College, Cambridge, which is where in 1687 Isaac Newton, inspired by seeing an apple fall off a tree, invented the theory of gravity. And we say that the moon is rising. Of course, the moon is staying stable. It's the Earth that is spinning. But the moon is moving round the Earth every 28 days. And when the moon is opposite the sun, the light is hitting the moon and it's then a full moon. When the moon is at one side, then only half of it is illuminated. When the moon is lit up from the back, then you only see a crescent. And Newton then could take his theory of gravity, and his theory was that the gravitational pull is proportional to the mass of the body divided by the distance it is away squared. So that the moon has a bigger gravitational pull because although it's smaller, it's closer, and it's the distance that really matters. So when the sun and the moon are opposite, they will pull out the water, creating a sort of oval of water within which the Earth will spin, and it'll spin round once a day, encountering 2 high tides and 2 low tides. And because this is the extreme oval, it's what's called the spring tides, the highest and lowest tides. Now imagine instead that the sun and the moon are pulling at angles against each other, then there'd be much less of an oval, there'd be much less of a difference between the high tide and the low tide. And that's what we call the neap tides. And then the Earth is moving round the sun, but it's at an angle. And when the northern hemisphere is facing the sun, that's when it's summer, that's when it's hottest. Around about the 20th of March, around about the 23rd of September, that's when we have the equinox. That's when the sun is perpendicular to the equator and is the greatest pull of water. And that's when you have the highest tides, the equinox tides. So the spring tide next to the equinox tends to be the extreme tide of the year. So Newton's theory explains a lot. It explains how we have high tides when the water's covered and when animals are feeding, while we have low tide where the mud and intertidal habitats are exposed so birds and things can go out and feed. It explains why we have spring tides when birds are pushed right up on the coast, and at low tide the very lowest parts of the coast are exposed, and neap tides when there's much less difference. And explains why we have these equinoxial tides where there are spectaculars at coastal sites because the birds are often pushed off the feeding areas and then come up in large numbers to roost, and it's often a very impressive sight. And all of this is due to the theory created here by Isaac Newton.